All right, in this video, we want to solve these questions over here. We want to integrate them and we want to use substitution over here in these questions. But if I take a look at these two questions, if I make my u the entire denominator over here and I derive it, derivation of a quadratic function is a linear function and the top is not a linear function. So I know those will not cancel off. And similar idea over here, we have a quadratic function. If I make that my u and I derive it, I'll not get a constant, I'll get a linear function. So I can't make the u the entire denominators in these ones. Instead, what I have to do is I have to recognize that these kind of look like the derivation of the arc trig functions. So like arc sine, arc cos, arc tan. For example, this one looks kind of similar to arc tan, and this one looks kind of similar to arc sine, but we've got to do a bit of manipulation to each of them to make them a bit better. So let's take a look at the first question over here. First things first is I'm just going to rearrange the bottom. It's not really necessary, but I like to do that because then it looks exactly like 1 over 1 plus x squared, basically, which is the derivation of arc tan. And then I want to make this number here a 1 and this number here a 1. I always want to do that. For the top, it's pretty easy. I can just pull that to the front because it's a constant. But in the bottom, I need to factor. So I'll start by just factoring my bottom. I'll common factor out of 4. And now I'm going to pull out this constant 3 over 4 to the front. So now it kind of looks a bit more similar to what I need. The next thing is I have to make sure that this term here is whole squared. So you want to square root this whole thing. So the square root of this whole thing is just square root 5. I can't square root that number. Square root of 4 is 2 and square root of y squared is y. And now that I have this whole squared, that will basically turn into arc tan basically by doing substitution. So I'm going to make my u whatever's inside this bracket over here. So u just equals square root 5 over 2 y. Going to derive this in terms of u. So du over dy equals, that's just going to be root 5 over 2. And then I have to isolate dy so that I can substitute it here. So I'm going to cross multiply the dy over to the other side. I'm going to cross multiply both of these to the other sides as well. So 2 du over root 5 equals dy. Now I'm going to do all my substitutions. Just replaced the bracket over there with u and then the dy with this over here. And now I can simplify this first before I integrate. So this 2 and this 4 will just cancel to be 1 and 2. So now I'm just left with 3. 3 times 1 is 3. 2 times root 5, so 2 root 5 integral 1 over 1 plus u squared du. Now we can just integrate this. That's just arctan right there. So 3 over 2 root 5 arc tan u and then plus c. And then final step, we're just going to replace the u back with root 5 over 2 y. So final solution 3 over 2 root 5 arc tan root 5 over 2 y plus c. Final solution for this first question over here. Second question is a slightly more difficult one, kind of similar, but slightly harder. Now, this doesn't really look like anything we have over there because we don't have a constant here, and we need a constant over here. I can't just factor out an x because that will no longer be x squared. So the trick to solving this question is to actually turn this into a perfect square. So we need to perfect square this over here before we can actually do substitution. So let's start by just rearranging it a bit so that we can perfect square it. So I'll actually just do the perfect square by itself over here. So negative x squared plus 8x. I'm going to factor out this negative. So negative x squared minus 8x. Then I'm going to perfect square it. So I'm going to take this number, divide by 2, and square that. I'm not going to explain how to perfect square in this video because that's grade 10 math, and hopefully you know it at this point. But if not, just go on YouTube, look up some perfect square videos. I'm going to take out the negative 16. And I'm going to multiply by the front. Then I'm going to just perfect square this. And then I'm going to rewrite it with the constant in the front so that it kind of looks more like the derivative of the arcsine function. So this is basically the same as that. I'm going to replace my integral over here with 1 over square root 16 minus x minus 4 square. Now that I have this over here, this is just an integration by substitution. Remember, before you want to do substitution, you always want to make these two numbers into a 1. At least that's how I do it. I need a common factor out a 16 over here. And then I need to do two things in this next step. The first thing is you need to make sure this 16 is outside the square root. So when I pull it out, the square root of 16, that's just 4. I'm actually going to write it out over here. I'm going to pull it all the way out just so that I can save a step. Don't have to take an entire step to do that. The second thing I have to do is make sure that this whole term here is whole squared. So square root of x minus 4 squared, that's just x minus 4. Square root of 16, that's just 4. This thing always has to be whole squared before you can do u substitution. Then you want to just make u whatever's inside the bracket over here. So u equals to x minus 4 over 4. When we derive this, again, this is not too hard of a derivation, but basically it's just the derivation of x over 4 minus 4 over 4, which is derivation of x over 4 minus 1 over 4. So du over dx, that's just 1 over 4. That will turn into 0. And then if I want to isolate dx, I'm just going to cross multiply this over and that over. So 4 du equals dx. I can do all my substitutions now. So over here, 1 over 4 integral, the integral of this whole thing. Oh, I gotta do my substitution first. Du is, dx is 4 du. This 4 and this 4 just cancel off. So now I'm just left with the integral of this over here. Oh, don't forget your square root. So now I'm left with just the integral of this over here. Integral of this is just arcsine u plus C. And then last step, I just need to replace the U back with x minus 4 over 4. So final answer for this question here, arc sine x minus 4 over 4 plus C. If you made it to the end of this video and you found this content helpful, please hit that like and subscribe button. Thank you for watching and have a wonderful day.